Welcome everybody to this Tuesday's Cloud Coaching Sessions. I'm your host. My name is Alex, and we will talk today about building an Oracle modern data warehouse to accelerate innovation with data. Today's presenter is Javier. Today's speaker is Javier de la Torre Medina, who is an EMEA, our data management autonomous specialist. And with that said, I'm just handing it over to Javier. Enjoy, everybody.
Thank you, Alex. So hi, my name is Javier de la Torre. I am a cloud data management specialist with a special focus over the autonomous database and data management solutions. And today I also have with me Javon, who is going to be as a panelist. So feel free to answer any question, to ask any question in the Q&A, as Alex mentioned. So let's start. So why do we need to build a modern data warehouse? So what is all this about? So let's start from the beginning, no? So we want to create a data warehouse because we want to create analytics, moreover because we want to be a data-driven company, okay? But when we want to be a data-driven company, when we look at the spectrum of the different applications that we have and we can run, we have a huge variety, no? For example, I can work with JSON documents because maybe I have a mobile applications, or maybe I'm building a cloud-native solution to make it quite efficient for the web browser, or even from a storing data point of view. Maybe I'm interested in using a graph data because maybe I want to identify the fraud. Maybe I want to do some kind of pattern analysis. Maybe I want to do a short path analysis. There are many use cases for graph, no? And moreover, we can talk about text. I want to create a search index because maybe I want to create a index catalog from my e-commerce because I want to analyze this data to understand it, no? Or I can work with spatial data because the location of my customers, the warehouses, all this information is very important for me, no? So we see that there is a variety of different kind of data. And also we have a variety of different kind of analytics, no? For example, I want to run machine learning, but if I want to run machine learning with different data, at the end I have to consolidate all of this data in a different place. So at the end, we are talking about data integration, data migration, or data even standardization to work with all these kind of different data, no? So at the end, when you are trying to build this kind of data warehouse, you are not a real data-driven company because at the end you are focusing in data integration or data movement. So this is not a good way or a good approach to do this kind of analysis if you want to use your BI tool. And moreover, take advantage of all these different capabilities, for example, for creating dashboards, as I was mentioning, no? So that's why we need a different way of doing this kind of analytics, the queries and this analysis, no? How can we simplify all these things to focus on the data and not in the data movement itself? So that's why one of the pillars for the Oracle Autonomous Database is what we call the Converge database. So the Converge is a set of capabilities in which we're going to allow us to work with different data types inside of the same Oracle database. So for example, I can store tables, of course, but maybe I want to store JSON natively. Maybe want to store spatial data natively. I can work with XML. I can work with graph. I can do blockchain tables. I can do a lot of many things, including machine learning, in the same Oracle database. Meanwhile, take advantage of all the different capabilities, which is very important because I can use just JSON capabilities for running, for example, mobile applications and so on, but I can combine it with machine learning or tables to get a new insight that before it was quite difficult, no? So at the end, I'm focusing on the data analysis and not in the data movement. So we're gonna see, the idea of the today's session is to see an overall integration to show you how it works in a specific customer use case. But before jumping into that, it's not going to cover today, but when we talk about a data warehouse, it's not important about how the data is stored in the Oracle database, which is very important because it can be the core of your data warehouse. But we know that the data can reside in many different places, as we talked at the beginning. And that's why the Oracle Autonomous Data Warehouse has the capability to read and connect to different data sources. So for example, I can use a Delta Lake architecture where I can read data that can be in a CSV, Avro, Parquet, and so on. maybe I can connect directly to different databases, for example, Salesforce or Postgres or Redshift or different solutions. So I can read the data live during a query, so I don't have to move data or do batch processing. And also, in case that I want, even I can do some transformation, for example, for data cleaning. But the idea overall is to simplify. I can run a query from a BI point of view, and I don't know if my data is in a Postgres, in a MongoDB, or in a CSV, which is stored in the object storage, even if it is a different provider. This brings a lot of great capabilities for become a real data-driven company. So let's jump directly into the session today, because today the session is going to be very practical. So it's going to be almost everything in a demo point of view. So don't hesitate to ask any question in the Q&A. So what is the story behind today of what we're going to see? So we're going to simulate that we are an e-commerce company, and we have a lot of customers that are registering that in a guest mode. So I don't know many things about them, because they buy, okay, I have an email, but I don't have too much information about them. So how can I enrich my data warehouse to get information that it is hidden from me? So the first thing that we're gonna use is Twitter. So a lot of customers are using social media to talk about the products, even to give them positive feedback, negative feedback. So the idea is that we're gonna download some Twitter data, and we're going to use the JSON structure that is already provided to do some queries analytics on top of that. But for that, we're going to do a simple sentiment analysis using the Oracle test that has double capabilities. So we can create like a search engine to search in the text for keywords and so on. And taking advantage of these capabilities, we can create a sentiment analysis. On top of that, as we are running transactions from our business, where we'll have customers that buying things and so on, so we're going to protect our transactions using blockchain tables. So we are sure that nobody can delete or do any kind of fraud. So we can only add information to that specific table. Then we're going to use Spatial to analyze the location of the tweets and combine it with the location of our warehouse to find new patterns. And then we're going to create an application with a technology which is called Apex, which means for Application Express, in which I can create an application without the need of create any kind of code. Okay, it's kind of a drag and drop utility to create these native applications. So there are more exercises that are not going to cover today for this session. So this is going to be a challenge for you to do some kind of homework to repeat these exercises. Don't worry, because we will provide the link to the exercises. So you can continue by your own to do all the same exercises and complement it. For example, use to predict customer churn using auto machine learning. And then you can identify influencers in Twitter. For example, who are my customers who are more like influencers. So I can, for example, drive a marketing campaign to talk maybe with them and to try to get more positive feedback, or to have this kind of marketing campaign as I was mentioning. So let's jump directly into the demo. And here, what I have here is the console of the autonomous database. The autonomous database is a self-managed database that the performance, tuning, patching, and everything is managed by Oracle. So you don't have to worry. You have to worry only about your data to become a data-driven company and to use all the capabilities that I showed you before. So what I'm going to do is going to go to my compartment, and here I'm going to create a new autonomous database. So in this case, let's define a name. For example, a modern data warehouse. This is going to be the type of data warehouse. I'm going to choose, for example, OCPUs, because I want to have just the smaller one, because this is for, I don't have too much data right now, with one OCPU, 1 terabyte of storage, and auto-scaling, so to have more resources when I need it. So I have a default user, super user, which is called admin. I'm going to introduce a password for that specific user. And from a network point of view, I'm going to make it public from everywhere. So it's going to be easier to show you the technology, although you can make this autonomous completely private, so nobody has access from the public internet. So I put my license and I create the autonomous database. As you can see, It's very easy. It's going to take just 1 or 2 minutes to create the autonomous database. But let's focus on the data, no? Because I was mentioning, the first thing that we're going to do is to talk and to collect the JSON data. So in this case, I have already downloaded the JSON data. So under the storage, I have a bucket in my object storage that I call it JSON data, in which I have all the data that I need for the workshop for today, in which I can contain the tweets, okay? A friend of, which is a relationship for the graph in case that you are interested in. And the revenue basically is a table when we have all the transactions, and we're going to create a table, a blockchain table on top of that. So we can see we have the data there. Let's see if our autonomous data warehouse has been created. It is provisioning, but it's going to take just a few, so we can see from the work request how it is going. So it is creating, it's going to take just between 1 or 2 minutes. So meanwhile it is creating, so I showed you that we have already the Twitter data. So the first thing that we're going to do is I'm going to take some notes because we're going to load the JSON data. So for that, I'm going to go back to the file. And from here, this is the full tweets. What I'm going to do is to collect, if we go to the view object, so this is the URL. So this is, every file is going to have an URL to make it like a cloud native. And I'm going to store it here, so I will not forget later on, okay? Also, something that we are going to do is that the autonomous database is a managed service, and for security reason, out of the box, we're not able to see anything among different services. So we need to create a token or an authorization so the autonomous can access to the specific files here, to read it and to load it later on. So what I'm going to do is I'm going to go to my user, which is called demo. I'm going to copy it because I'm going to need it also for later on. And as I was mentioning, we're going to need an authentication token. And here is going to be like the token to access to the object storage to load the files. So let's create a token. This will show only once. This is something I use for the password. So I'm going to store it here for later on. Meanwhile, it is creating the autonomous database. Let's have a look because I think it's going to be already created. And we can see this already is up and running. So let's jump into it. And the first thing that we're going to do is we're going to jump into the database actions. So database actions, I call it like the iPhone. Why? Because you have a set of applications that makes it very easy to use. You don't have to have any kind of previous experience in working with Oracle to work with the autonomous database. So we're going to see that we're going to have a SQL developer web. We're going to see that we have a way of working with JSON that we're going to do. So we have many things, no? And the first thing that we're going to also do is we're going to create a specific user, okay, to work with the autonomous database. So let's create a specific user. You can see it very intuitive. I'm going to click on create a user. And I'm going to call it, for example, CNVG. And I'm going to set a password and limited quota. And I want to use, for example, graph and web and machine learning. I want to access all the capabilities. So I create that specific user. And now I can log out from here. And let's jump directly because I want to use this specific user. So you see how easy it is to create the user, right? We have the same exactly graphical interface. So now let's start loading the JSON data, okay? So we have the token, we have the user, we have the URL because we collected all the information. So basically we need to grant access, no, with all this information. So for that, we're going to go to SQL. And we have a specific command, which is create credential, that I'm going to call it a JSON credential. So we have the username, which is my demo. and also the token, which is the password. Okay, so we are ready to load the JSON data. But before that, we're gonna jump into the JSON menu that I showed you before. So from here, what I wanna do is to create a new collection to store our data. That, for example, we're gonna call it sample tweets, because we want to store some tweets there directly there. And I can insert, for example, a single document here. Let me copy a sample tweet that I have here. So you can see that, well, already we have some a negative feedback and all the information about the tweet and the Twitter user itself, no? And with create, so you can see that I have already this Twitter information here. But of course, I don't want to insert one by one. I want to insert in batch everything that I have already there, no? So that's why I'm gonna jump into SQL, because we have an utility which is called a copy collection. Let me delete this one. So basically what we're going to do is to load into the sample tweets collection with our credential, and now we're gonna put the location from where we have the URL. Okay, so we run it. Okay, so we saw that it works. And the good thing is that I can combine SQL and JSON. So for example, if I do a select count, we should see some data there, because we have already one. You see, we have already a total of 20. So it loaded everything that I needed. And also I can show the JSON data natively here with the JSON serialized, because I want to see the raw data. So we can see all the different information about the tweets. And even I can run some simple SQL queries directly here if I want. Because, for example, I want to see the reply count, the text, if the tweet has been retweeted or not, and so on. And also, if I'm not comfortable with SQL, I can go back to the JSON. And for example, I can run a simple query to, for example, to see that a specific tweet, for example, with ID 510. So it is already filtered. Okay, and if I run, you can see all the different documents that I can edit and modify here. So this was the first part of the exercise. Okay, so we have the Twitter data there. So now the next thing is I want to do some sentiment analysis on top of that. So for that, we're gonna create a materialized view, because I want to create some specific indexes on top of that. So from here, I can create a view directly from here. I can click on add all. So you can see if I click on the test query, this is the statement to run a SQL query over all the different elements that Oracle is providing out of the box for me. But in this case, I don't want to create a view, but a materialized view, because I want to create some indexes. So I'm going to take advantage and the support that I get from the utility, from the JSON. But in this case, the only thing that I'm going to do is to change and say that in this case, I'm going to create a materialized view. It's something that I'm creating by myself. Okay, so we can see it directly there. And if I do a select all from materialized view tweets, we can see the JSON data as a standard table also. So I'm hiding the complexity for the final user. So what I'm going to do, some requirements that we need for the search engine is, for example, I want to create a primary key based on the ID, and then I'm going to create an automatic dictionary that is coming out of the box with Oracle, which is called the auto lexer, which basically contains like good words and bad words. So basically, you can do a sentiment analysis. Although you can create your own dictionary, but in this case, we're going to use the out of the box one. And once we define this preference, we're going to create this sentiment index based on the lexer that we defined before. And from here, already we can use and run some simple sentiment analysis. Okay, so the index is created. Let me delete it. The output to make it more clear. So, and I can run, you can see, use the sentiment analysis directly on the materialized view twist that they have there. Okay, so you can see there that already have something, a sentiment which is a number. It is between -100 and 100. So if it is negative, it means it is a negative feedback. If it is positive, it means that it's a positive feedback. So this maybe is gonna be not very intuitive. So the first thing that we're gonna do is to create a table using the same query, because I want to store the data for later on for sentiment analysis. And also what I'm going to do is to create a new column. I'm gonna add a new column in which I have like if it is negative, neutral, and positive based on the sentiment that I showed you before. Okay, so you have seen that is how easy it is to create the sentiment analysis, just creating the index and running a specific query. So we have the emotion. And also, as I was mentioning at the beginning, another capability that they have with the Oracle text is not only about the sentiment analysis, but also to be able to do a search in the text. No, so for example, let's search on the text, which is the tweet itself, all the tweets that are talking about the shipping, because I suspect that my customers are not very happy about the shipping. So automatically it's gonna filter the information, and we can see already some information about the shipping. Okay, so we can have all the information containing that. So you can see that is very simple. So we have seen how to create to work with the JSON data. We have created some sentiment analysis. Now let's jump into the blockchain tables. No? I want to focus on my relational data from my e-commerce. No? So in this case, what I'm going to do is to create a blockchain table. So in this case, I will go, I'm here in SQL, so I'm gonna create a table based on the CSV because I already have some information. Let me make it clear. Okay, so basically the only thing you have to do to create a blockchain table is to put blockchain on top of the table one. And also you have some information here. So for example, you cannot drop a database if somebody is doing changes, and if there is nobody doing changes, for example, in 16 days, then you can drop it. And also I can set that the no delete, okay, because I want to be sure that nobody is deleting the data on top of that. So I have some kind of flexibility. So I'm gonna create the table, okay, and basically now that I have the table, I'm gonna load some data there, okay. So in this case, I have the data load. In this case, I'm gonna load it from my local file. So let me find the CSV data. You can see you can have a drag and drop. And in this case, well, I have in the object, but I'm gonna load it in from my local laptop. So you can see a different way of loading the data. So I show you one way using JSON. So I will show you the other one. So I have here my CSV, which is called the revenue CSV. Okay, and I can start loading here, but in this case, you can see here I can do some settings to do some modifications. So instead of creating a table, what I'm going to do is to insert into a new table, which is called the revenue that I have here. Okay, and even I can change the data type, the column, and so on. Okay, but the tool is smart enough. I'm not going to change anything because it works very well. But always is good to double check. So I'm gonna run the run job, in which is gonna load the data. No. So it is complete, only 30 rows, just for demo purposes. So let's go back to the SQL. So in this case, for example, let's have a look into the data that I have here. If I do a select all, so for example, I have some information about the shipping, the employee who is selling this product, the order of the product, when it has been billed, the order status, it is paid, on hold, the currency, because maybe in supporting different countries. So you can see a lot of information about where my customers are buying, right? So even we saw that it was around 30 rows, but we can do a select count, so we can do any kind of any query there that we have there. No. So how do we know that we have a blockchain table? So we have a table which is called user blockchain tables. So we should see that we have a table which is called revenue. Okay, so we have some information about the hash algorithm that has been there. No, it's not a standard table. No, so we have let's have a look into that specific table more in details about the blockchain table, looking about the revenue table. No, so we're gonna see that we have more columns. Okay, so we go here, so you can see that we have some tables that are not defined for me. Okay, for example, the chain, the hash, the signature. So this is something that Oracle has done out of the box, okay, for me, which is hidden, but I can see that specific table, and even though I can query that specific table, no, column, sorry. So I can run this query to select that specific columns that are hidden, no. So you can see a bit of information about the revenue table itself, okay? But we can see that, for example, we are querying we can see the hash that automatically has been populated. But now, as it is a blockchain table, so for example, if I do an update, let's see what happens. Okay, so in this case, it's a blockchain table. I'm not allowed to do an update on the table. In this case, what I can do is I want to do a new insert about this specific table, no? Because it's designed in this purpose, because I want to have like a book of what is happening with all the transactions to check all the historical status. So that's why I'm using this blockchain table here, no? And also, as we saw, as for example, if I try to drop the table, we're gonna see that there is an error. I cannot drop that specific table, no? But also, even if I have the concern that somebody can do something that is not expected, because maybe I'm missing a security policy about a user or so on, we have a small PL SQL code that it is documented, of course, in which basically is gonna verify all the rows, basically checking the hashtag to be sure that everything is right, no? So basically, let's run it. I put a simple an output. So I have a total of rows, which is basically the select count, and also the verified rows that are showing that everything is fine are the 30 rows, no? So there is no problem there. So nobody has tried to do something or has modified the data underneath. So it's a way of securing the data. Now we're going to the next chapter. So we have my transactional data, but I want to get more insights about my tweets. And in this case, I want to use the location, no, to see if there is any kind of issue or problem there. No, let me delete the output. And something that I'm going to do that I think is going to be very, very meaningful is I'm going to create a table which is called my warehouse. Okay, so basically, an e-commerce I have established in Germany, in which I have a warehouse in two places, in Frankfurt and Düsseldorf, and here I have the latitude and longitude. So I'm gonna combine the location from my warehouse with the location from the tweets to see if there is something there. No? So let's create the warehouse table. So this is correct. So now, basically, what I'm going to do is to use the spatial capabilities of the autonomous database. So in this case, I have something which is called a function which is called CDO geometry. So basically, this is what I use is to use the longitude and latitude to calculate the distance in kilometers. So for example, I want to draw a circle, and for example, I want to check the tweet's location in a range of 100 kilometers, 200 kilometers, to see if there is a problem in the comments and so on, right? So in this case, I'm gonna use this specific function, okay, because I want to make it aware. I think. Okay, so I have my specific function there. And now I have to create some metadata to define that we're going to use internal metadata, saying that we're going to use the materialized view tweets on this specific function. Okay, and this is based on a standard. There are different standards of calculating the distance and so on. You can check it in the documentation, but we support a great variety of flexibility when we doing this calculation, right? But we're following the standard. So now with all this metadata that we have defined about the specification of the geometry, the standard way of calculating the latitude, the longitude, and so on, we're ready to create an index using the spatial function. So this is going to speed up all the operations that we're going to use for calculating distance and so on. Okay, so the index has been created. So in this case, let's start running some analytics. So let me clear the output. In this case, for example, I want to get the location, for example, and I want to calculate the distance outside of 250 kilometers. No, sorry, inside. So if I run a simple query, so basically I'm comparing, for example, the Frankfurt warehouse with the different location from the tweets, no? And in this case, well, it's not calculating the location, but we can see some the information about which are the location of the tweets that are writing inside a distance of 250 kilometers. No, so we have some people writing from Colonia, Düsseldorf, or Dortmund. No? So let's run another query, but in this case, instead of using inside of a distance of a circle of 250 kilometers from my Frankfurt, I'm going to do it from farther away. No, so in this case, I'm using the same query, but basically saying a not, no, like a negative operation to calculate the outside of the circle that I'm using with the spatial geometry. So we can see the data that was missing from the other query. So we have people from Varsovia, Oslo, Rome, Paris, and the distance in this case from the warehouse. No, it is around 900 kilometers, 1,000 kilometers. So in this case, what I'm going to get advantage and is to run the query to add to the query to the motion. I want to see if it's positive or negative the tweets that are farther from 250 kilometers. So I'm going to run the query, and we can see that all the tweets that are farther from 250 kilometers are negative. Okay, and also we saw at the beginning that many people were talking about the shipping. No, so we can see that we have people complaining about the shipping. Maybe it was not the best one because maybe we're not getting emails or official complaints, but we can see that in social media they are not happy. It's taking longer than expected. So we can see that using Twitter data and our internal information, we're getting information that at the beginning is like a hidden, no, to do this kind of analytics, and just with a few SQL queries, we can run this simple query and simple analytics. Okay, so this is great. So we have run all this kind of analytics from a SQL point of view, but maybe it's not very business oriented. So I want to create a dashboard to show all this information to my different business users, or to my C-level, to show the results so they can run queries to see what is going on using all the analytical capabilities that we showed right now. So in that case, what we're going to do is to use, we go back to the modern data warehouse, we're going to use Apex. So Apex is a low-code development, so we can create queries, applications without the need of creating any kind of coding. So basically, we can copy the URL, and let's paste it here. And we're gonna connect to the Apex instance automatically. So we're gonna connect with the default admin user. Let me put the password. And the first thing that I have to do is to create a workspace. It's a logical environment. So for example, I can create a workspace for production applications, or for example, for HR application, or for ERP applications, or by department. So it's a logical separation, okay? For us, it's just a matter of creating a new one just for creating our application. So we have an existing user that contains all the data, which is CNVG, that we already created. I'm gonna connect CNVG also, but let me copy and paste the password for that specific workspace. So this workspace is already created. So we can go here from the link, and even we can log into the admin part of the application express. Okay. So in case I have different applications, we can see a list here, but we don't have any kind of application. No? So in this case, what I want to do is to create a new application in which, for example, I want to create a new chart. No? So let's create a new application. In this case, because I want to use the same data which is stored in the CSV. So for example, let's call it data insights. And for example, I want to change the icon to red. I want to put a rocket because I want to spike innovation to become a data-driven. We're going to be faster in making business decisions. And let's add a new page to my application. In this case, you can see that we have a different kind of applications or pages that I can create. For example, even a map, reports to modify data, and calendar. There's a huge variety. But in this case, I'm going to create a dashboard because I want to create some analysis about the data that I have. No? So what I'm going to do is to create some dashboard. So for example, let's create one which is called sentiment results, because I want to see what is going on my business. Let's use the table which is called sentiment results. And for example, I want to search by emotion, and I want to do, for example, a count over the emotion to see how the customers are talking, and for example, a pie chart. No? Let's create a second chart. So in this case, I want to see the Twitter information. So let's create something which is called top followers. In this case, let's go to the materialized view tweets. Okay. Let's, for example, go by name. And I want to do, for example, the followers. I want to check about the followers because this information is important to me to see who is an influencer, right? Also, for me, it's important to know as a business person, the revenue. So I can create a new chart, which is called a revenue. I can create a bar chart. And let's talk about the revenue data, which was a blockchain table. I have it here. So for example, I want to select the order type. See if I find it, order type. And for example, I want to do a sum on the revenue. And finally, I'm going to run a last chart that is going to call it, for example, a location popularity. I want to understand from where my customers are buying, right? So for example, let's go back to the Twitter table, which is in this case was the materialized view table. And for example, let's look for location. And also I want to do a count in the location because I want to see the count of the people who is buying. Okay, so with this, I can click on add page. Also, I'm gonna add all these kind of capabilities and capabilities. I'm gonna check all and click on create application. And automatically, Apex and the autonomous databases create this dashboard and this application directly for me. It's gonna take a few seconds to run. Remember that you can ask questions in the chat, in the Q&A. So you can, you have any curiosity, you can put it there on the chat. Okay. So we can see that automatically Application Express has created all these pages for me that contain all the information, so I can enter and modify details, color, and everything with a very intuitive application. But in this case, I'm going to run the application. I want to see the look and feel before I do anything. No? So in this case, the user was CMVG. Let me paste the password. So we can see that we have one page, which is called a dashboard, okay, that we can access also from here. And we can see the dashboards from all of them. No? So we can see that we have the half of the tweets are negative and a few of them are neutral. So we have a user 4 that has a lot of followers. So maybe it's important to check if this customer has positive or negative feedback about our products, because can influence, or maybe we can do a marketing campaign because maybe it's an influencer. Also, we can see the kind of revenue and top revenue that the different products that I have in my e-commerce, no, everything related to security is bringing more revenue to my company. And also we can see that I have a variety of customers buying from different places, no. So I can cover it Europe. That's why it's important that the shipping is became from negative to positive. So I have my customer fidelity to keep buying. Okay. So we have covered in the workshop everything. Okay, so we have covered all the exercises, and as I mentioned, there were some optional exercises, which was the auto machine learning and using the graph to find influencers in the social media with from Twitter, right? So in this case, what I'm going to share with you, that I had it here. So this is the same workshop that has been running with you. So you can access it via a public web page, which is Oracle Live Labs. You can go to Google and look for Oracle Live Labs and look for the exercise or the live lab, which is called Modern Data Warehouse. And here you will find all the different exercises that we have run today. And these are the bonus content that they give you as a challenge. And don't hesitate to connect to Slack and ask any question if you have any issue, concern, or you have curiosity of the different capabilities. But the next exercise that I think will be quite interesting is to create a machine learning model without the need of coding. Basically, define what are the predict column, for example, the affinity card, if my customers have an affinity card or not, to predict and see what are the common characteristics that make my customers buy again or not. No? And you can see a small spoiler that where the emotion, if they are happy or not, is important for them. No? And you will see how to make this machine learning in production. And finally, you will use graph to identify influencers using the social media. But I will not jump into it because I will let you work and play around with these exercises. So this is the end of the session. So we have some time left. So if there is no specific question, so Alex, back to you.
With that said, thanks everybody for attending, and check out our Slack channel and our email addresses for contacting us and reaching out to us if you have any questions.